Hey everyone, and welcome back for another deep dive. Today, we're going to be talking about something that's really got me excited, sustainable architecture. And specifically, we're going to be looking at how aluminum, something we normally associate with like soda cans and tinfoil, is being used to create these like incredibly strong buildings and eco-friendly buildings.
Yeah. It's really interesting. It really challenges the way we think about building materials.
It totally does.
Yeah.
And the cool thing is, this isn't just some futuristic concept. It's already happening. So the source that we're looking at today is called Pioneering Sustainable Architecture, the Aluminum Revolution in Building Design. And it details how this company, M.H.S. Building Systems, is using this their award-winning structural aluminum framing design to build buildings up to 60% faster.
Wow. That kind of efficiency is a game changer, especially when you think about it. A project that might normally take a year could be done in just a little over 5 months. So that's significant cost savings and minimizes disruption, especially in busy urban areas.
Yeah, that's a huge difference. But before we get too far ahead of ourselves, I think it's important to step back and look at the bigger picture here. The construction industry is facing all this pressure to be more sustainable, more efficient, and adaptable.
Yeah, absolutely. You're right. A lot of the traditional methods are struggling to keep up with those demands. So there's this search for new solutions that are better for the planet, faster to build, and can really adapt to our evolving needs.
So how does this aluminum system address all those challenges? Because I'm still trying to wrap my head around how aluminum, something I usually recycle, can be the backbone of a whole building.
Right. Well, it's pretty remarkable what they're doing. It's not just simply substituting one material for another. They're using cutting-edge technology, like aluminum extrusion, to create these incredibly strong and lightweight components that can be assembled very, very quickly and efficiently.
So aluminum extrusion, is that like where they're squeezing the aluminum through a mold?
Yeah.
To create like specific shapes? I'm picturing like a giant Play-Doh fun factory.
You're not far off. It is more sophisticated than that, of course. But the basic idea is similar. They heat the aluminum and they force it through a die to create these very precise structural shapes. And the exciting thing is they're using specialized alloys like 60-61 and 70-75, which are known for their exceptional strength-to-weight ratio.
So it's not just any aluminum. They're using specific types to make sure that these buildings are strong enough.
Exactly. These particular alloys are as strong as steel, but they're significantly lighter. And then they enhance that strength even further by using a heat treatment process called T6, so it's all very carefully engineered, to optimize the properties of that material.
Okay, so we've got these strong lightweight components, but how do they actually all fit together to create a building?
Right, well, that's where these interlocking connectors come in. These connectors are really like the missing piece of the puzzle. They securely join all of those extruded aluminum components together to form the building's framework.
So it's like a giant 3D puzzle.
Yeah.
But I have to ask, are these aluminum buildings really as sturdy as those built with traditional materials?
They are indeed. Extensive testing has shown that the unique design of these interlocking connectors ensures that loads are evenly distributed throughout the structure, making it incredibly stable and robust. Not only can they withstand various structural loads, but they're also designed to meet stringent safety standards.
That's really impressive. So we've covered strength and efficiency, but you mentioned sustainability earlier. So where does that come into play with aluminum construction?
Yeah, well, sustainability is really woven into every aspect of this system, starting with the material itself. Aluminum is 100% recyclable, meaning it can be reused over and over again without losing its structural integrity.
That's fantastic. So we're reducing waste from the start. But what about the actual construction process? Is that environmentally friendly too?
Absolutely. The lightweight nature of the system means you need less heavy machinery on site, which automatically reduces fuel consumption and emissions.
Okay, so less pollution from transportation.
Yeah.
And construction. That's a big plus. But what about the building itself? How do they make it energy efficient?
One of the key elements is the use of structural insulated panels, or SIPs. Think of them as a giant pre-made sandwich for your walls, with a core of super efficient insulation, nestled between sturdy boards. These panels are integrated seamlessly with the aluminum framing to create a building envelope that's practically airtight.
So it's not just keeping the building warm in the winter and cool in the summer, it's making the whole structure more energy efficient.
Precisely. The combination of the aluminum frame, the interlocking connectors, and those SIPs results in a building that uses less energy for heating and cooling, which is good for the environment, and your wallet,
This is all starting to sound very appealing, but are there any downsides? Are there any limitations to what you can build with this system?
That's a great question, and it's definitely something we should delve into. Because while there are many advantages, it's important to understand the full picture. One thing to consider is the cost. I imagine a system this advanced must come with a pretty hefty price tag. So is that like a barrier to
Yeah.
wider adoption?
Yeah, that's a good point. I was thinking that too. It's like, this sounds great, but can anyone actually afford it?
Right. Well, it's a common perception, but it's
Mhm.
not always the case. While the initial upfront cost of materials might be slightly higher than traditional methods, you have to factor in the long-term savings
Like all the reduced construction time, lower labor costs.
and energy savings.
Exactly. The
Yeah.
faster construction times mean you're paying for labor for a
Yeah.
much shorter period. And the energy efficiency of the building translates to lower utility bills over an entire lifetime. So when you consider all of these factors, the overall cost can actually be quite competitive, sometimes even lower than conventional construction. Wow, okay. So you really need to look at the whole life cycle cost, not just the initial investment. But let's talk more about the design aspect.
Yeah.
You mentioned that this system doesn't sacrifice architectural flexibility, even with those standardized components. So how's that possible?
Yeah, that's a great question. The beauty of this system lies in its modularity. Think of it like a sophisticated grid system where all the components fit together seamlessly. Architects can use this grid as a framework for their designs, creating a wide range of configurations while still ensuring structural integrity.
Okay, so it's like having this giant set of building blocks, but with the added benefit of knowing that
Yeah.
whatever you create is going to be structurally sound.
Exactly. It allows for incredible creativity within a framework that guarantees stability and performance. In fact, the source material even mentions that they've designed buildings with like complex curves and cantilevers using this modular system.
Wow. So we're not just talking about like boxy utilitarian structures. You can actually create some pretty impressive architectural feats using this system.
Absolutely. And the source even highlights a few award-winning projects that showcase the aesthetic possibilities of aluminum construction. There's this one example of a stunning museum in Europe with this flowing organic facade that was entirely created using this
A
system.
museum, that's pretty far from those boring metal buildings I was picturing.
Yeah.
So do you think that's like a challenge, like changing people's perceptions of what aluminum construction can be?
It definitely is an ongoing challenge. People tend to associate aluminum with industrial or utilitarian structures. But as more architects embrace this system and really push the boundaries of design, I think those perceptions will continue to evolve.
Yeah, it sounds like this is a perfect example of how innovation can sometimes be held back by like outdated perceptions. But I have to ask, is this system suitable for all types of buildings? What about something like a high-rise apartment building or a hospital?
That's where the system's adaptability really shines. It can be scaled to accommodate projects of various sizes and complexities. The source mentions a few projects where they've used this system. For mid-rise and even high-rise buildings, they've even built hospitals and schools using this technology.
So it's not just limited to single-family homes or small commercial buildings. You can really go big with this.
Yes, and what's really impressive is that they've also done extensive testing to ensure the system can withstand extreme weather conditions and even seismic activity. The source mentions a project in a seismically active region where they use this system to build a multi-story hospital that's designed to withstand earthquakes.
Okay, now that's impressive. Earthquake resistant and versatile. I'm starting to see why. There's so much buzz around this technology. But I have to ask about the environmental impact again. We talked about aluminum being recyclable. But what about the manufacturing process itself? Isn't that pretty energy intensive?
It's true. Aluminum production does require a significant amount of energy. However, advancements in manufacturing technologies and the use of renewable energy sources are making the process more sustainable.
So it's not perfect, but it's getting better.
That's right. And when you compare the environmental impact of aluminum production to that of steel or concrete, aluminum actually has a lived carbon footprint over its life cycle.
Really? So even though it takes a lot of energy to produce, aluminum might actually be a more sustainable choice in the long run.
Exactly. And don't forget, that aluminum can be recycled indefinitely without losing its properties. This means that the aluminum used in a building today can be reused to create new buildings in the future, further reducing its environmental impact.
Okay, I'm seeing a lot of potential here.
Yeah.
We've talked about the structural advantages, the design flexibility, the cost benefits, and the environmental considerations. But I'm curious about the human side of things. How does this system impact the people who actually build these structures?
That's an important aspect to consider. The lightweight nature of the components makes them easier and safer to handle, which reduces the risk of injuries. On construction sites,
So it's potentially safer for construction workers.
yes, and because the system is designed. For rapid assembly, construction times are shorter, which means workers are exposed to potentially hazardous conditions for a shorter period of time.
That's a significant benefit. It sounds like this system could lead to a safer, more efficient construction industry overall. But what about the people who live and work in these buildings? Are there any advantages for them?
Absolutely. We've already talked about the energy efficiency, which translates to lower utility bills for occupants. But beyond that, the airtight construction and the use of high-quality insulation materials create a more comfortable and healthier indoor environment.
So it's not just about saving money. It's about improving the overall quality of life for the people who use these buildings.
Precisely. Studies have shown that buildings constructed with this system have better air quality, reduced noise pollution, and more consistent temperatures, which can lead to increased comfort and well-being for the occupants.
That's a really positive takeaway. It sounds like this system is not just about changing the way we build, but also about creating better spaces for people to live and work in. But before we get too carried away, with all the benefits, I think it's important to address the elephant in the room.
You're talking about the potential challenges and limitations.
Exactly. Because no system is perfect.
Right.
So what are some of the hurdles that need to be overcome for this technology to become more widely adopted?
That's a great point, and it's something we should definitely explore. One of the biggest challenges is just getting the word out there, overcoming those outdated perceptions of aluminum construction and showing people what's truly possible with this technology.
Yeah. It's like saying the hardest part about building something new is unbuilding the old.
Yeah.
But what about the practical aspects? Are there any logistical challenges to implementing this system, on a larger scale?
Well, one challenge is the availability of skilled labor. Because this system is relatively new, there's a limited pool of workers who are trained and experienced in its installation. So as the demand grows, we'll need to invest in training programs and educational resources to ensure we have a workforce that's equipped to handle this type of construction.
Makes sense. It's like any new technology, you need people who know how to use it properly to really unlock its potential. But beyond the workforce, are there any other, infrastructure or supply chain hurdles?
Yeah, that's another area where we need to be proactive. The manufacturing and distribution networks for these specialized components are still developing, so we need to ensure that there's a robust and efficient supply chain in place to support the growing demand for this type of construction.
So it's not just about having the technology, it's about having that whole ecosystem in place to support it. But let's zoom out for a moment and consider the bigger picture here. We've talked about the benefits for individual buildings, but what about the potential impact on the built environment as a whole? How could this technology change the way our cities look and function?
Well, imagine cities where buildings are constructed faster with less waste and disruption. Cities where structures are lighter, more adaptable, and better equipped to handle the challenges of climate change. This technology has the potential to revolutionize urban planning and design.
It's like opening up a whole new toolbox for architects and urban planners. But with all this talk about innovation and progress, I think it's also important to consider the potential downsides. Are there any unintended consequences we need to be aware of?
One concern is the potential for increased reliance on a single material if aluminum becomes the dominant material in construction. We need to ensure that we have sustainable sourcing practices and robust recycling systems in place to avoid depleting resources or creating new environmental problems.
So it's about being mindful of the entire life cycle of the material, from extraction to disposal.
Exactly. We need to make sure that our enthusiasm for this innovation doesn't lead to short-sighted decisions that could have negative consequences down the road.
That's a crucial point.
Yeah.
It's about finding that balance between embracing innovation and being responsible stewards of our resources. But let's shift gears a bit and talk about the social implications of this technology. How could it impact communities and everyday lives?
Well, the potential for faster, more affordable construction could have a huge impact on addressing the global housing crisis. Imagine being able to quickly and efficiently build safe, sustainable, and affordable homes for people in need. This technology could be a game changer in terms of providing shelter and improving living conditions for millions around the world.
That's an incredibly hopeful thought. It makes you realize that innovation isn't just about cool gadgets and new materials. It's about solving real-world problems and improving people's lives.
Yeah.
But as we wrap up this deep dive, I have one final question. If we look beyond the technical aspects and the practical applications, what does this aluminum revolution tell us about our relationship with the built environment?
I think it highlights a growing awareness of the need for more sustainable, adaptable, and human-centered approaches to construction. We're moving away from the idea of buildings as static, permanent structures and embracing a more dynamic and responsive approach.
So it's not just about the buildings themselves, it's about a shift in mindset.
Exactly. It's about recognizing that the built environment is not separate from nature, but rather an integral part of it. It's about designing structures that are in harmony with the environment and that contribute to the well-being of the people who use them.
Beautifully said.
Yeah.
Well, I think we've covered a lot of ground today, from the technical details of aluminum extrusion to the potential impact on our cities and our planet. This has been a truly fascinating deep dive.
It's been a pleasure exploring this topic with you, and for those who want to learn more, we'll be sure to include a link to that source article, Pioneering Sustainable Architecture, the Aluminum Revolution in Building Design, in the show notes.
A huge thank you to our expert for sharing your insights, and to you, our listeners, for joining us on this journey of discovery. As always, we encourage you to keep exploring, keep questioning, and keep diving deep into the world around you.